That's me, Abdurrahman. Today, I'm gonna show you how to solve the rate of change using derivative. So let's start. First, we need to know the derivative. The derivative tells us the rate of change of one quantity compared to another at a particular instant or point. So we call it instantaneous rate of change. This concept has many applications in electricity, dynamics, economics, and so on. So today we're gonna use the velocity as an example to learn how to use differentiations to evaluate it. We learned before that velocity is distance divided by the time, but this only works if the velocity is constant. It doesn't move, means it doesn't move. So, but we need a new way to solve the velocity if it moves, changing all the time. If we have an expression for s, which is the displacement, in terms of t, which is the time, then the velocity at any particular instant t is given by this equation, v equal to the limit of the change in s over the change in t, all of them when t approaches to 0. To make the algebra simple, we will use h for delta t, for the change in t, and write it like that. V, velocity, equal to the limit of f of t plus h minus f of t over h when h approaches to 0. For example, we will take an example of that. An object falling from rest has displacement s in centimeters, given by s equal to 490 t squared, where t is the time in seconds. What is the velocity when t equal to 10 seconds? Let's see how to solve it. Take note that s equal to f of t, so we use f of t instead of s in the previous example. The answer is, first, we will evaluate the equation, the main equation that we will use to solve it. So we have v equal to the limit of f of t plus h minus f of t over h when h equal to, or no, sorry, not equal, approaches to 0. Now we sub in the values that we have given in the example, so become the limit of 490 t plus h all square minus 490 t square or all over h when h approaches to 0. So now we will solve the equation t plus h and expand it to t squared plus 2ht plus h squared minus 490 t squared over h. Now we cancel we simplified the equation, the numerator. Then we got 490 times 2h times t plus h squared. Now we can take the h as common factor, and we will cancel it out with the denominator like that. Final one, we got the limit of 490 times 2t plus h. We forgot to mention that we cannot sub in h equal to 0 because it will be undefined, because h here in the denominator, when the denominator equal to 0, then the equation is undefined. So we cannot do that from the first time. We have to cancel out the h in the denominator. So let's move. The final one, the final equation is 980t. So v, the velocity, equal to 980t is the expression that tells us what the velocity is at time equal to or more than 0. When t equal to when t equal to 10 seconds, as he required for the question, v equal to 980 times 10, which is 9,800 centimeters per second. So the velocity at t equal to 10 seconds is 98 meters per second. Thank you.